71? Really?
I thought yesterday you made us.
All right, 71. All right, whatever. 11, 15. Okay. This is function notation for combining functions. We're spending a couple days on this topic. Today we're doing the easy thing, and is that in focus or out of focus? I can't tell. My contacts are just totally messed up today. Is it good?
Yes.
Okay. All right. So the key with combining functions today is we are taking functions and we are either adding them, subtracting them, multiplying them, or dividing them. That is what we are doing today. And it can be easy or it can be hard based on your knowledge of the notation. So this is the notation. This is the new terrible notation that I absolutely hate. The only reason that we have it is because you'll usually in actual math life, we won't write the of x, okay? We would just write f plus g, or f minus g, or fg, or f over g. So that's the shorthand, that's okay, all right? But all this means is we're going to take our f function and add it to our g function, and we're going to leave it in terms of x, okay? In terms of x. So you're going to combine some things, but there's still going to be x's in your answer, okay? So really, this is the old school notation where we would have just written f of x plus g of x. Take your f function and add it to your g function. Fg, two things right next to each other. There is multiplication in there, so we're multiplying functions. And then f divided by g is just f of x over g of x, dividing two functions. And of course, since we have a fraction, then what do we know about the denominator? Can't be 0. The denominator is not allowed to be 0. So we always want to just take into account the exclusions, okay? The places where it becomes undefined. So really, this is just notation, and it's so important that you understand the notation. So let's see how this works a little bit. Find f plus g, f minus g, fg, and f over g. Also specify the domain for each. Ugh.
Is it important?
Yeah. Okay, now I know you're going to get this a lot, but when will we use this?
Actually, this is like the most important thing for calculus, but the problem is they don't do it in the right way. So you actually need to do this graphically, and then it would be much better. Yeah.
So wait, why is it done this way?
Just so you can work on your algebra skills and mostly to learn domain.
Oh.
Yeah. So domain is the big thing, recognizing what values we're not allowed to use. So what I want to talk about first is we have f of x here, negative 3x plus 5. What shape is that graph?
It's linear.
It's linear. It's a line. Yeah, it's a downhill sloping line. It is linear. I don't really care what the graph looks like, as long as we understand that it's a line, because if you have a picture in your head, then you can think about the domain of it. If it's a line, what's the domain? How far left does it go? Negative infinity. How far right does it go? Positive infinity. So our domain is from negative to positive infinity. All right. G of x is x squared minus 2x minus 8. Parabola, very good. And if you're thinking about that parabola and it extending forever, what's the domain of our parabola? It goes forever to the left and forever to the right. So remember, domain talks about the x-axis. So if you have a picture in your brain, thinking about domain visually is a wonderful way to think about domain. That parabola goes forever to the left, it extends out to the left forever, and extends out to the right forever. All right, it's a good place to start, just getting a picture in your brain. When the domains match, that's very, very helpful for us. We want to find f plus g, and it's literally just taking our f of x function, negative 3x plus 5, and adding the g of x function, x squared minus 2x minus 8. Wow. And so we get what? X squared minus 5x minus 3. And there's your f plus g in terms of x function. And if you look at the shape of that resulting function, what's its domain? Good. Its domain is a parabola, meaning it goes forever from left to right. So negative to positive infinity. All right, so addition of functions is super easy when they're so nicely, okay, when they're nice. It's not always easy. What do we have to be careful of if we're going to subtract two functions? The sign, the negative, just messes everything up. So f is the negative 3x plus 5, and I want to subtract the entire g function. So that's the problem, meaning that you need to do what with your negative? Distribute your negative. And of course, a lot of you I know can do that in your head, and that's fine. But you do need to distribute your negative and then combine like terms. So we get negative x squared minus x plus 13. Good. And that's f minus g in terms of x. And again, what shape is it? Parabola. What's the domain? Negative infinity to positive infinity. Good. Yes. Yes, it is. In fact, for every polynomial. All right, so FG. FG means multiply. So we're going to take negative 3x plus 5 and multiply it times g, the x squared, minus 2. God, this is boring. Sorry.
What?
Let's just take it down. So we get the concept.
So you can multiply this, right?
Yes.
Yeah? Oh, okay, great. What's going to be the leading term? What's the highest power? X cubed. Okay, good. Negative 3x cubed. Good. And that's a cubic function, so what's its domain?
I don't know that.
What's the shape of a cubic? It's squiggly. Yeah. So this is like a roller coaster graph, really. When in doubt, you could plug the answer in your calculator, look at the picture, okay, and how far left and how far right does it go. Great. I'm glad you guys are cool with not doing any more work.
Wait, you always gotta ask for that.
Do we have to write them out each time?
What? Well, that's why you only have 1, 5, 8. You don't have 17 of them. You have like 1. Yeah. Okay. So you guys can multiply that all together. Do some excellent distributing. I trust that you can multiply that. Fine. F over G. That's not hard. Negative 3x plus 5 over x squared minus 2x minus 8. That is all I can do. But I do need to figure out the domain. So tell me about the division problem, because this is a problem.
Forget that.
So denominator domain, right? We know that this denominator is not allowed to equal 0. I can factor that.
Oh.
X times x is x squared. What times what is negative 8? Negative 4 and positive 2. Which means each of those bubbles is not allowed to equal 0. Which means x cannot equal 4. and x cannot equal -2. And that is our domain, denominator domain. Anytime you have a denominator, you need to figure out the excluded x's. Okay?
Is that only if it's in like
Uh-huh.
That is.
Yep. Just because the denominator. Yeah, it's a crazy graph, right?
so on the the things you assigned out.
Yeah.
You want us to write out like negative infinity, infinity, or can we just put?
This is fine for this type.
Okay, we can just.
Yeah, the easier way to write it, yeah. Instead of interval notation, yeah. Okay, that's good. These are stupid question, right?
Oh yeah.
Right? Okay. There are such things, it turns out. So oh, you guys are great. Okay. These were polynomials, and most of that stuff is pretty easy. Things get more complicated with these square root functions. So let's talk just briefly. I cannot take the square root of negative numbers. I cannot take the square root of negative numbers. So all the stuff on the inside of any square root function must be greater than or equal to 0. It must be non-negative. So anytime we have a square root function, we're going to have a restricted domain. What does the shape of a square root function look like? A swoop. What's the domain? Does it go forever? No, it does not. Okay. So the way we find that domain is we can set up our little equation here that says the inside must be greater than or equal to 0, which means x must be greater than or equal to -2. So the domain for this first one is x is greater than or equal to -2, which is a fine way to write it if you want. You can also think about the graph. We did this yesterday. You know the square root swoop. This square root swoop is shifted to the right or to the left? To the left 2 units. So if you were to go and graph that, it shifts left 2 units, and it's this way. You can see the domain goes from -2 all the way to infinity for x values greater than or equal to -2. Okay? G. What is the domain of G?
D is greater than or equal to
So x is greater than or equal to +3/2. Very good. Again, same idea. If the inside must be greater than or equal to 0. Solve the equation. Okay? All right.
I feel your soul.
My soul is dying. Is that what you said?
I said I can.
You can feel it. I'm so tired. I've been all week waking up an hour before my alarm,
Taking naps, get
Which
ready
is
for the weekend.
4:30 in the morning.
Oh my gosh.
Awful.
That sounds like
So, yeah.
Jonah.
All right.
What?
Here, f plus g is the square root of x plus 2 plus the square root of x minus 3. Are those like terms? No, they are not. Okay? I can't do anything with that. And figuring out the domain is complicated. No, because actually we've done most of the work already, which is why we found the domain to begin with. So we have 2 square root functions, and we have to go with the domain that works for everything. Okay? So when I look at the domain of x, this square root of x plus 2 here, we said it had to be x values greater than or equal to -2. Well, I could graph that. I'm just going to show you this first one. Let's see, that's -2 right here. All right, and that's everything to the right. Good? Yeah? Okay. We also have this square root function. It has a restricted domain as well. And its domain, we already said, was x must be greater than or equal to 3 halves. Well, 3 halves is here. And greater than or equal to means it must be to the right of that. Since they're both representing this function, we have to do the domain that works for both. Yes. Meaning, where does it overlap? Yes. Okay. So what works for both? Right here, from 3 halves all the way to infinity. We go with the most restrictive domain is how that works. 3 halves to infinity. You could write it that way. You could also say x is greater than or equal to 3 halves. Either, I don't care how you write it. Okay, so you have to, when you have a function, you have to look at each part and think about the domain of each piece. And we go with the most restricted domain. Okay. So for instance, if I plugged in 0, I get an answer here, but here I get imaginary. So I can't do that. Okay. So I plug in like a 5, I get an answer out there for both of them. So 5 works, but 0 doesn't. All right. F minus G. So that's going to be F, square root of x plus 2 minus the square root of 2x minus 3. Are those like terms? No, they're not. I can't do anything. That's the answer. And again, thinking about domain, we have to investigate each piece, but we already know the answer because it's going to be the same. X must be greater than or equal to 3 halves for the same reason as above. I have to look at the domain of this square root function. I have to look at the domain of this square root function. And then we go with the domain that works for both parts. Okay? Does that make sense to you? No, domain is so confusing. So it will take time. It's not an equation that we're solving. We're just simplifying an expression.
So,
Probably in this.
So let me, when in doubt,
graph it out.
okay, so if you wanted to, you could graph your functions. This is my f minus g function. And if I look at it, it's kind of a goofy graph. And guess what where it starts is? 3 over 2, right there, 3 over 2, 1.5. And it goes forever to the right of 3 over 2. So the domain is 3 over 2 to the right, everything greater than 3 over 2, okay? So if you're ever like, I'm not sure about domain, when in doubt, graph it out. Plug it in and see what it looks like. All right, FG, square root of x plus 2 times the square root of 2x minus 3. This one you actually can simplify a little bit. Totally you can. Yeah, because we can do like the square root of 5 times the square root of 7. And what's the square root of 5 times the square root of 7? Square root of 35. Yeah, so because they're both under a radical, we can multiply them together. So it's actually going to be...
Awesome sauce.
Yeah, you do have to FOIL it. Ooh, I kind of like writing it in bubble form. That's actually nice. 2x squared minus 3x plus 4x minus 6. So there is your FG simplified. This is also very crazy, the domain. I'm going to go ahead and check our domain graphically because, you know, when in doubt, whoops, cry it out. All right, I'm going to go ahead and leave it in bubble form. Those bubbles are going to be real useful for us when we go to look at the domain. X plus 2 times 2x minus 3, all underneath my radical. All right, graph that. So we plugged this whole thing into our calculator, and then we get this crazy graph.
Oh,
All right, that's what the graph looks like. What do you think this point here is on the left?
-2.
-2. Guess where that came from?
Oh.
Right there. Huh? What do you think this point is? 3/2. Yes, I can trace and see those points are actually there. That -2, and I can type in 3/2, and it's right there at 0. What's the domain then? How far left does this arrow go? Negative infinity all the way to -2, bracket. Union, it picks back up again at 3/2. And how far to the right does it go? Infinity. So domain. It's actually a really great question, and always domain. Just look at the graph. Easiest thing to do. Crazy.
Oh, this would be close.
Oh man, this is just getting worse and worse. All right,
Is there more after this?
there sure is.
Whoa. Division is just opposite of
Grab help that. All right, so f over g, x plus 2 over the square root of 2x minus 3. I'm going to leave it like that. We could put it under a giant radical, but it's not any more simple. But again, this whole function, this is it. That's all we can do, really. But we need to figure out the domain, and this is a very complicated domain. Is it what? Diameter. I don't know what you're saying. D is domain.
Yeah. Why would you
What? Domain? You're saying diameter. Okay. Domain.
Don't everyone's tongue.
Okay. Oh, yeah. Denominator. There we go. Oh boy. Okay.
It's Friday.
All right.
What are you talking about?
Noel, do you know what you're talking about?
All right. Here we go. So because once again we have a function that has multiple complications here. Because the top has a radical and it has a restricted domain. X must be greater than or equal to -2. We already know that. This one, we already know the domain of the square root of 2x minus 3, but
How crazy is that? This
Oh,
one,
yeah.
normally, okay, listen up. This is super important. Normally, we would say that the inside of that function has to be greater than or equal to 0, since it's a square root function. Okay. And that's fantastic, except that it's also in a denominator. Is it allowed to equal 0 in the denominator? No, it cannot. So it actually just has to be, it must be greater than 0, which means the domain of this would be x is greater than 3/2. Okay, so once again, we have a combo domain. A combo domain. The domain of that numerator says you got to be bigger than -2, like that. But the denominator says you got to be bigger than 3/2. So what's the domain of the whole thing? 3/2 to infinity. Do we use a bracket or parenthesis at 3/2?
Bracket.
Parenthesis. It's an
Yeah.
open circle. We're not including 3/2.
yeah.
Okay? So the domain is 3/2 to infinity. Very tricky. This is like pre-cal. This is pre-cal. That's a lot.
Shouldn't that be
No, because we're not allowed to equal 0 since it's in the denominator. Okay.
This is the last one, then.
I think it's gonna be the last one. This is called the difference quotient. This is gonna be the last one because I'm pushed. This is called the difference quotient. It's actually fine because the difference quotient is the foundation of calculus. It is how calculus was derived. Okay. The nice thing is once you do this a bunch, you no longer have to do it because you'll learn a bunch of shortcuts. But the algebra is super important. Okay. So this is the difference quotient. It's called the difference quotient because there's a giant difference sign, subtract, and it's in a quotient. It's a division problem. So this is exactly what we're finding. And again, we're not solving anything. It's really just simplifying an expression. So first of all, if I told you find f of 2, what would you do? Plug 2 in place of the x, and you would do like 2 squared minus 3. 4 minus 3 is 1, right? All right, so if it was a number, you'd plug it in. So what do you suppose f of a plus h tells you to do? Plug in, replace x with the a plus h. So I'm going to go to my f function, and I'm no longer going to use an x. Instead of an x, we're going to use a plus h. So I have my something squared minus 3, and I'm going to plug in a plus h. Then there's a big difference sign. And now this says find f of a. What does f of a tell you to do? Yeah, plug in, replace x with an a. So in f of, instead of x, we use an a. So we're going to have,
Is the one line is subtraction?
yeah.
Is it one of the word problem things?
No. Usually h is a small change. It's really the slope formula. It comes from slope. But
Is this how we get to it?
yes.
Okay, that makes a lot.
All right. Now I'm going to go ahead. We had to subtract the entire function, so make sure you always use parentheses. And I need to do a plus h quantity squared. How do you do that?
A plus h times a plus h.
All right, a plus h times a plus h, which is what?
A squared plus 2h squared.
2 what? H squared, good. Minus the 3. What do I have to do with this negative sign?
Distribute.
Distribute it. So we get,
Recording is about to stop.
I know, I'm almost done. So, all right, distribute the negative, and then combine like terms. Oh, man.
Everything's just happening.
All right. A squared and negative a squared cancels out.
This is so awkward standing there talking
You distribute to
She cannot pronounce her last name,
20
but I
more
think her
seconds.
first name is Mila.
All
Do you want to leave?
right, thanks.
How do you pronounce it?
Got 10 seconds.
Do not say that.
All right, and negative 3 and a positive 9 gives me a 6.
5 seconds.
Oh, sorry, over H.
2.